Hi everyone, so I'm continuing with my series on CSEC Math past paper revision questions, and this one is from January 2018. We're looking at question 5, which normally has to do with the measurement, and in this particular question there is a topic called polygons, which doesn't usually come in CSEC, so that's why I wanted to do this question, right, because it very rarely comes in CSEC. So we have a regular polygon EFGHIJ shown below has center O. Triangle OEF is equilateral and EF is equal to 5 centimeters. So part 1 for 1 mark, what is the name of the polygon shown above? So this is very easy. We just have to count up the number of sides in our polygon. We have 1, 2, 3, 4, 5, 6. So 6 sides means that this is a hexagon. All right, so let's look at part 2. Calculate the perimeter of the polygon EFGHIJ for 1 mark. Okay, so they already gave us one side of the hexagon, 5 centimeters. So the perimeter, since there are 6 sides, will be 6 by 5, which is 30. Okay, so that's an easy 2 marks so far. So let's go on to part 3, which says determine the size of each interior angle of the polygon for 2 marks. Now the interior angle of the polygon, right, would be each of these angles here at the vertices. All right, so there is a particular formula that is used to find the sum of the interior angles in any polygon. All right, so the sum of the angles in a regular polygon is given by this formula, 2n minus 4 multiplied by 90 degrees, where n represents the number of sides in the polygon. So since we have 6 sides, we substitute n as 6. So we get 2 by 6 minus 4 times 90. So 6 2s are 12, take away 4 is 8, so we have 8 times 90, and that will give us 720 degrees. Now, they asked for the size of each interior angle in the polygon. So each interior angle will have to divide the sum of the angles now by 6, since there are 6 sides in our hexagon. All right, so 720 divided by 6 will give each interior angle to be 120 degrees. So let's go on to the 4th part. Show by calculation that the area of the polygon to the nearest whole number is 65 square centimeters. And this is for 3 marks. Okay, so we need to find the area of the hexagon. So let's go back up to the diagram. Okay, so just going to erase this. All right, so let's look at triangle OEF. So they told us that this triangle is equilateral, right? So therefore all the sides are 5 centimeters. And not only that, if the triangle is equilateral, it means all the angles would be 60 degrees. So now that we know that, we can find the area of triangle OEF and multiply that by 6 to get the area of the entire hexagon, because this hexagon is actually comprised of 6 congruent triangles. All right, just like triangle OEF, right? That's what congruent means. Same size, same shape. So you have 6 of these triangles inside of the hexagon. All right, so let's find the area of triangle OEF, and I'm going to draw it down below. right? So we have OEF, right? Each angle 60 degrees, and each side 5 centimeters. Okay. So, since we have all three sides and all three angles, we can use this formula that is given in the formula sheet. So, area of triangle OEF, a half AB sine C, which is actually a half times the two sides times the sine of the angle that is in between the two sides. So if we apply that to our triangle here, a half times, if we look at these two sides of the triangle, OE and OF, so it's a half by OE by OF by sine of, and the angle in between those two sides would be 60 degrees. Now in this case, it doesn't matter which two sides you use and which angle you use, because all the sides are the same and all the angles are the same. So we'll get a half by 5 by 5 by sine of 60. And using our calculator, we get 10.83 to 2 decimal places, square centimeters. So therefore, the area of the hexagon, we take this area now and multiply by 6. Oops. So 10.83 multiplied by 6, and you will get 64.98 square centimeters, which is approximately 65 square centimeters to the nearest whole number, which is what we were required to show. Okay, so that's your 3 marks.